Hey, Fabio.
Hey boss, what's going
All right,
on?
should we move beyond theory to real cases? Oh, so let me orient you first. So here's
Yeah.
the game we're gonna play, right?
Actually it's 4 spectrograms, and these correspond to the 4 groups of electrodes in the double banana montage. So we have left lateral, right lateral, and then we have left and right parasagittal, right, sort of, or paracentral. They're near the middle.
Okay.
The insides of the bananas.
Okay.
And then the time base, it looks like this is about, well, it's in minutes, and so this is more than 1 hour. You can see it goes to, looks like around, I don't know, 65 minutes or so.
Okay.
All right, so with that in mind, and then there's a little green square at the top. Yeah. So what we're gonna do is you're gonna try to guess what you would see if you looked at the 15 seconds of EEG where that green square is.
Okay.
And I think the options are, just to make it easy, right? So the options are, you can see seizures. Or if you could be in the middle of a seizure, you could see LPDs, lateralized periodic discharges, GPDs, generalized periodic discharges. You can see LRDA, lateralized rhythmic delta activity, GERDA, generalized rhythmic delta activity, or you could see none of the above. And when you see none of the above, what else could it be? Well, it could be focal slowing that's not rhythmic. You could see generalized slowing that's not rhythmic. You could see burst suppression, or you could see a whole bunch of artifacts.
Okay.
So I think those are all the options. So,
Cool.
All right. So you got to try to guess what you're going to see.
This looks really pretty. So what could possibly be going on here?
So there's a lot of flame-looking things, a lot of hills. The power.
Actually, we do call these little patterns flames, by the way.
Okay.
In fact, we call them regular flames. That's to contrast them with choppy flames or irregular flames. You'll see some that are much more jagged in later slides, but these are regular flames.
The regular flames. Okay. So it's on the 4 panels, but it's more so on the right, right to the left. The power seems to go up progressively, and then it kind of goes down faster than it went up.
Yeah, so there's some evolution in the frequency of the activity underlying this this spectrogram.
Okay. And not only the frequency, but even the spikiness.
Yeah,
because it's going all the way up. Okay, got it. Yeah, so that's I'll cheat, because every time I remember flames, I remember seizures.
Yeah, because regular flames almost always are seizures. That's a valid inference.
Okay.
So, and actually, are these seizures focal or generalized?
Yeah, I think they're more on the right side, even though we can see some on the left. So I would say I'll guess focal.
Yeah, they're very asymmetric.
Okay.
And how many seizures does this patient have?
Oh, I think it's a lot.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28.
Yeah, in a little more than an hour.
Right.
So having seizures every few minutes. These are cyclic seizures.
Cyclic seizures.
That's our guess. Yeah.
Yes. Okay.
Let's take a look.
Okay. Ta-da!
Yeah. So actually, if you just only saw this, actually 10-second segment of EEG, what would you call this?
Yeah, so I see there's something different on the right temporal or lateral, so that goes with that. It's hard to see the evolution just looking at 10 seconds, right?
Yeah.
So maybe LPDs.
You might say, call it right-sided LPDs. You maybe see a hint of evolution, seems to be maybe speeding up near the end, but I agree, you can't really tell on this scale, whereas it's easy to tell on the spectrogram.
Yeah, right.
Okay. Let's do another example.
It's really red everywhere, so it's generalized because it's everywhere, and it's high power, so it's red.
So you think it's symmetrical left and right?
I think so, yeah.
Yeah. Okay. So it's something generalized.
Something generalized. Start with that. And then I think there's even higher power at the bottom here because it's even redder. Does that word exist?
Yep.
Redder. Okay.
Darker red.
Darker red at the bottom. So that would be around, if that's 5 hertz, that would be around like delta, probably like 3 hertz or something like that. And I think it's spiky because the power is extending all the way up. So requiring those faster frequency components we learned last time around to fit the bill of that waveform. So I think it's spiky too.
Okay, so you're guessing there's something probably periodic, giving the low frequency, high power, and that periodic thing has a pointy shape, and that's explaining how broad the sort of high power is on, it goes all the way up past 5 hertz. What would you guess that underlying pattern is?
Yeah, so let's see. So it's generalized. It's periodic because it kind of goes up and down really fast, but still goes up and down. So periodic. It's sharp, it's spiky, so probably discharges. So GPDs then.
Yeah, that's a good guess. And so here's the name for this pattern that we see here is so note, unlike the flames, which were a bunch of discrete, individual events, this is pretty much long stretches where it's staying more or less the same, right? So we say it's monotonous because it's not changing for a long time. I mean, there is a change somewhere a little bit before 30 seconds or 30 minutes. So maybe there's 2 segments. Each of those segments is its own monotonous, long changing event. And then and then it's because the band, this little red band, goes up more than 5 hertz. We say it's broadband. It's a wide or broad. So this pattern we call broadband monotonous. And typically, if you see broadband monotonous and it's generalized, you're going to infer that is GPDs. If it's broadband monotonous just on one side, it's probably LPDs. Right. Now, not invariably, so you do have to check, but that's the best guess when you see broadband monotonous.
I see. Okay.
Let's see what we have here. Bam.
Yeah. Beautiful.
GPDs.
Yeah. So discharges, pretty generalized, pretty periodic. Okay, nice. It worked.
At about 1 hertz.
Yeah. Cool.
Yeah. Sweet. Let's look at another one.
This one.
Okay. Oh, tell me about this one.
So this was connected at the 20-minute mark. Start with that.
Yeah.
It looks like a flame too.
What kind of flame?
It still looks pretty regular, I think.
Regular flame.
Yeah. But maybe the upgoing is faster than the downgoing slope this time around, maybe?
Maybe.
Hard to say, right?
Yeah. I think this one goes woo.
Okay. Yeah. Okay. And then, so every time we see flames that are regular, we think seizures.
Yep.
They're everywhere here on the 4 panels, so maybe generalized.
Yeah.
But not this one, right? This is too much.
Yeah. What about that one?
Is it just like artifact?
That's probably artifact. Yeah.
Okay.
Yeah. Usually, because it goes across the entire spectrum, and it doesn't seem to evolve. It seems pretty abrupt. Typically, that's an artifact.
Should we look at the answer?
Let's do it. Yeah, by the green square. So yeah, we're in the middle. We're at the the beginning of a seizure.
Yeah. Perfect. Cool. Got it.
Let's
Sweet. Next.
another one.
All right.
All right.
Man, this is hard.
Nah.
Let's see. Start from the basics that I already know. So first of all, it's everywhere. 4 panels, so it should probably be generalized. Hard to find a real band. It's really broad, so it's getting all the way from really 0 to almost 10 hertz.
Yeah.
So somewhere around there.
Would you call that a broad band?
Yeah, I would. That is kind of monotonous too, right? Because it's kind of stays the same.
Yeah,
Yeah.
it bores me to death.
Yeah.
Broadband monotonous.
Yeah. Okay. And because of that extension up there, it means probably that it's spiky, right?
Yeah.
Spiky component. It kind of looks like the GPD example we just looked at.
Yeah, yeah. Whenever we see broadband monotonous, we guess periodic discharges. So this is
Okay.
a generalized pattern, so probably GPDs.
Okay. Should we
Yeah.
the verdict?
Ta-da!
Nice.
Sure
Okay.
enough.
Okay, fits.
Yep.
Cool. Sweet. All right.
All right.
Awesome.
Oh, okay. 2 seconds to say what you guess this is.
GPDs.
You got it. All right, go. Let's see. This is broadband monotonous. Yep.
Yeah.
All right, for extra points,
Oops.
what was the underlying diagnosis?
Wait. Let me go back. What was the underlying diagnosis?
Yeah.
That was, I would say maybe arrest, cardiac arrest, hypoxic brain injury.
I agree. Why do you say that?
So in addition to the GPDs, the background is really suppressed in between. Really
Yeah.
suppressed.
Right. Yeah, this is typical of a severe anoxic, global anoxic brain injury.
Gotcha. Okay. Perf. Next.
Yep.
Okay.
Oh,
Oh, this is different.
something different.
Yeah. Okay. All
Okay.
right. Let's take a stab at this. So more on the left. So the first focal guess on this episode. So more on the left. So focal, whatever it is, it's focal. Now looking at the band, it's still broad. So it goes all the way from 0 to around 5, right? And it's the chi power extends above, so it's probably spiky. So we have the focal, we have the spiky, it's monotonous,
Yeah.
right?
So
So
it's a broadband monotonous pattern, but it's lateralized this time.
lateralized this time. Okay. So LPDs.
Most likely LPDs, but let's look what's going on the other side.
It's a good question. I was hoping you weren't going to ask me that.
You can run, but you can't hide. Just in terms of patterns, spectrogram. So I would call the places where it's a little higher amplitude on the right. So it's definitely not, broadband monotonous. It's not broad enough, and it's kind of choppy, right? So it's not actually that monotonous either. So it's this might be maybe we could call these choppy flames here and there, little. They're not like the seizures that we saw before, the regular flame.
Okay.
So these are probably choppy flames or maybe narrow band monotonous. I mean, it's actually, I'm not sure we have a good term for these, but they're not one of the interesting things. And then in between those things, it's just narrow band monotonous. It's kind of very low power, thin little band, not changing much. So probably nothing interesting is going on. It's probably just focal, or it's probably just slowing that's irregular, is my guess.
Okay.
So, all right. So we're guessing LPDs on the left is what we're going to see here overall.
Yeah. 1, 2, 3. You're right.
Yeah. So sure enough, we have LPDs at like 0.5 hertz, and then on the right is just kind of boring, irregular slowing.
Perfect. All right.
Okay, I'm gonna do this one with no glasses on.
You can do it in your sleep.
Narrow band. Actually, this is broadband monotonous on the right. LPDs.
Yeah. Okay.
Although actually, okay, so here, the band, you might ask, is it really broad? And I would say, it's pretty borderline, but I'm still going to go with broadband monotonous LPDs. I just bet that they're a little bit blunter than the other ones we've seen.
Okay. We don't have a cutoff to call it broad or narrow, do we? It's just like
I've been using 5 hertz.
Okay. Got it. Okay, cool. Sweet. Should we look at the
Let's do it.
verdict?
Yeah.
Yeah.
So sure enough,
Yeah.
1 hertz, or a little less than 1 hertz, maybe 0.75 hertz LPDs on the right, and they're not particularly pointy.
Yeah. Okay.
Yeah.
That's why the band is kind of in the middle of the way, probably, right?
Yeah.
Okay. Cool.
All right, let's see about this one.
Oh my goodness. What's
All
this?
right.
These are
Yeah.
choppy flames. Choppy flames.
Choppy flames.
Yeah.
What do you guess these choppy flames are?
I think they're just none of the above.
Yeah, they're probably artifacts. It looks like the EEG is not on the patient's head in that part of the recording there.
Okay. And then, yeah, so this is another use for this, right? When you're unsure if the patient is connected or not, and you're starting to look at EEGs, look at Spectrogram to help out, right?
You can find the parts that are probably just artifact. Yeah. So
Cool.
then how about what's the pattern outside of the artifact part?
Yeah, so more on the right, so it's focal. It's kind of narrow and a little bit spiky, but not too much, still narrow. So Lerda
could be right-sided Lerda, or it could be what else?
Or it could be just focal irregular slowing.
Yeah.
Okay.
I'm going with you. I bet it's Lerda on the right.
Okay. Should we have the honor?
Let's do it.
Cool.
Ah, sure enough. Right-sided Lerda.
Got it. Beautiful. Okay.
All right, let's see another one.
Another one.
Okay, yeah. What's the pattern here?
So it's narrow, it's everywhere. But it's kind of choppy too at the same time, right?
A little bit, yeah. There's some waxing and waning of whatever it is.
It's so many of whatever it is, right? So could it be just generalized?
We'll say the pattern first.
Oh, the patterns first. So it's narrow. It's narrow band. It's kind of monotonous.
I think it's kind of monotonous.
Yeah. So Gerda or generalized irregular slowing?
Yeah, I think, and so one thing that clues you into Gerda or Lerda is that the band is well, it's monotonous. It's more, it's kind of consolidated. There's less choppiness than in the other examples. I bet this is Gerda as well. Although again, I wouldn't be surprised completely if it was irregular generalized slowing.
Okay.
But I'm going to bet on Gerda.
Okay. And you think that's artifact?
So that, yeah, I would look at that thing. It doesn't look especially suspicious to be a seizure, but you never know for sure until you take a look. But yeah, I think it's probably an artifact, probably some movement artifact or something.
Okay, cool. Should we look?
Yeah.
Should we peek?
Oh,
cool. You're right.
Gerda is a good call.
Nice, Gerda. Okay.
This is different.
It looks very blue.
So what does very blue mean here?
It's low power.
Yeah, low power.
Yeah.
What else do you notice here that's different? We haven't seen this before.
It's really striped.
Stripy, yeah.
Yeah.
Yeah, we call this pattern stripy. What does stripes mean on the spectrogram?
Yeah. So maybe nothing and then something, nothing and something, nothing and something. So maybe nothing, something burst suppression-ish.
Burst suppression, yeah. Yeah, and when it's right, that's what it is. It's burst suppression.
Got it.
Now tell me before we look, are the bursts do they have epileptiform activity in them or not?
I don't think so.
It's hard to tell at this scale. I think that they do go up above 5 hertz most of the time though.
What do you do? Okay.
Yeah, if you look, the bright, kind of yellowish part goes up. So I think these may have spiky parts.
Okay.
Let's take a look. I could be wrong. It's a lot of blue, so I'm wrong.
Yeah. Or maybe you just got the blue part mostly.
I'm pretty sure I'm wrong. You're right. Yeah, but it's burst suppression.
Okay, got it. Nice.
Actually, for our readers, do we
Uh-huh.
want to circle the bursts?
Oh, yes.
I think you can see them, but
So burst here, kind of asynchronous. And
yeah, a
then
little asynchronous, but
nice.
there's the bursts. Then these
Yeah.
are the suppressions.
Nice.
I'm not, this drawing is not the best, but
Cool.
okay.
Perfect.
Ah, this time they're spiky.
They have to be.
Yeah, these are these are angry bursts.
These are those highly epileptiform bursts.
Yeah, these are stripes with spiky bursts in them.
And less suppressed too, right? Is that fair to say?
Well, there's less of the EEG is suppressed. I guess the suppressions are probably briefer.
Mm-hmm. Yeah. So yeah, so it's a good way to estimate the suppression burst suppression ratio too, right? If you look at the spectrogram.
Yeah, you could. Yeah, you could. I guess. So what would you guess it is here?
I don't know, like 30%.
Yeah, that's my guess. Maybe 30, 20 or 30.
Okay. Cool. So should we look?
Look, let's do it.
All right. Nice.
Yeah, I think we're right.
Beautiful. Yep. So the burst is longer, right?
Yep.
And spikier.
Mm-hmm.
It's
And the suppression is not a complete suppression. It's
yeah,
still got some background activity. It's not very flat.
yeah.
But I think that's just happened. I think there's other parts where it's more flat. It's more. Aha.
All right.
So just to wrap up, so we're just showing the different patterns that are useful to know to infer what's in the EEG. So
Okay.
let's take the B first. So there's you can see there's 1, 2, 3, 4, 5, 6 panels in each thing here.
Uh-huh.
We're going to ignore panel 3 and 6
3.
because those are asymmetry spectrograms, and we haven't talked about those.
Okay.
B is an example where there's a whole bunch of little flames on the left side.
Mhm.
So these are regular flames,
Mhm.
and these are only left-sided regular flames.
Mhm.
And so these are almost always seizures.
Okay.
If we go down to D is, we would call this just suppressed,
Okay.
right? And this is usually just low amplitude EEG, not much going on.
Mhm.
F we would call narrow band monotonous, right? There's that little thin band at the bottom.
Mhm.
And this is either, if it's either rhythmic slowing or non-rhythmic slowing, but it's not seizures or periodic discharges.
Okay.
Then over in E, those are those sort of choppy flames, or actually this is just artifact.
Mhm. Mhm.
Yeah, we'll just call that artifact.
Okay.
If we go up to C, that looks like it's broadband monotonous, right?
Mhm.
And so if it's symmetric, that's probably GPDs. There's a little asymmetry here, but I think it is probably GPDs. So broadband monotonous is
Okay.
periodic discharges most of the time. And then up in the upper in A, what we have is actually these are the choppy flames, these choppy flames,
Mhm.
and they're usually nothing of interest.
Got it.
Usually movement or state changes, but
Okay.
almost never seizures.
Got it. Beautiful.
That's it.
Thank you, boss.
Now you know.
That's beautiful. You brought a lot of colors into my life in EEG reading practice.